Today we are going to be learning about mean value theorem. And mean value theorem is basically the mean or average rate of the change of f on the interval a, b, and that's the closed interval. And the mean value theorem is basically another way, it's kind of like a branch off from roles, I guess. Roles can be used to find like this. Okay, so we have conditions in which we can use mean value theorem. And the function must be continuous on a closed interval. It also must be differentiable on an open interval. And there exists a number c and the closed interval a, b, such that f prime of c equals f of b minus f of a all over b minus a. That's basically all you need. These all have to be correct for you to be able to use mean value theorem. So we're going to try an example problem now. Okay, let's say that we have to find the value of c. So find value c. Okay. Simple enough. That satisfies MVT for the function. So you have f of x equals x plus 48 over x on the interval 3:16. Okay, now if we were to graph this function, we would see that it is continuous on a closed interval and it is differentiable on an open interval. So, let's see if there exists a c, which there does. Okay, so first we're gonna have to write all those things down to get some credit. Now we are going to kind of see our givens, I guess. Okay, so we know that this is a and this is b. Now a equals 3, b equals 16, f of a equals, we have 3, well basically equals x plus 48 over x. That's 3 plus 48 over 3, and we know that's 3 plus 16, so that's 19. Now we have f of b, which equals, let's see, 16 plus, x plus 48 over x, that equals 16 plus 48 over 16, and that's just 16 plus 3, and that is also 19. So, when we plug this back into this equation right here, we're going to see what we get. But first, we have to find the derivative because it says f prime of c. So to find the derivative, actually, sorry about that. We're not going to find the derivative of that function, of that right now. We're just going to plug everything in. Okay. So that's what we're going to do. Okay. So we have f prime c equals f of b minus f of a all over b minus a. So f prime c equals f of b, which we found is 19, minus 19 all over 16 minus 3. So we know that equals 0. So we're going to set 0 equal to this derivative right here. So we're going to take that off to the side. F prime c, f of x, we're going to say x plus 48 over x. Now we're going to have to do the quotient rule here. So we have 48 over x. you know that u prime equals 0, v prime equals 1. So we're going to have v u prime minus u v prime all over v squared. So that equals v x times u prime, which is 0, minus u, which is 48 times v prime, which is 1, all over v squared, which is x squared. So we know this derivative equals negative 48 over x plus this x. Sorry, x squared plus that x. Okay, and we're going to have to find the derivative of this, which is 1. So we have negative 48 over x squared. It's 1. Okay, so we're going to set that equal to this thing. So this part, 1 minus 48 over x squared. What we're going to do, move it over, so we have 1 equals 48 over x squared. Multiply that over, x squared equals 48. So x equals the square root of 48. Or c equals the square root of 48. Okay, and that's our answer. It's our C. Thank you. Signing off. Goodbye.